So we've got a question here. We've got 23x squared minus 8x plus 34 is congruent with 0 modulus 77. Now this question here, we want to find how many solutions there is and if they are infinite or not. So that's what we're going to do with this question. So first things first, this modulus here, 77, obviously not a prime number. So 77 is the same as 7 times 11 as a product of its primes. So we need to break this question down into two parts to start with and try and solve for an x modulus 7 and modulus 11 first. So let's go with that first. So I'll do modulus 7 on this side. So 23x squared minus 8x plus 34 is congruent with 0 and modulus 7. Okay, now let's see if we can break this down a little bit more. So as we've got modulus 7, we can reduce these coefficients by factors of 7. So obviously it's 23, looks like it can be brought down to 2x squared. This minus 8x, obvious way to start would be minus x. And this plus 34, well 7 5s are 35, so reduce that by 35, bring that to minus 1. And congruent with 0, modulus 7. Now 2x squared minus x minus 1. Now we could do quadratic formula, but this looks to me like it will factor out. So if I write this as some products of factors, and I'll have a 2x and an x. Now we want minus 1, so we want a plus 1 and a minus 1. So as minus is the coefficient here, minus 1, I want the minus 1 here, and then plus 1 in this one here. So if I multiply this out, I'll get 2x squared plus x minus 2x, which would be the correct one, and then minus 1. Okay, so now as this congruence comes to 0, I've got one of two things happening, or both. 2x plus 1 is congruent with 0 modulus 7. So therefore 2x will be congruent with minus 1 modulus 7. So and modulus 7 minus 1 is the same as 6. So that's congruent with 6 mod 7. So therefore x is congruent with 3 modulus 7. So that's the first one. Now let's look at this x minus 1, a little bit more straightforward. So if I start off, x minus 1 is congruent with 0 modulus 7. X is then congruent with 1 modulus 7. Now notice here with these two results, 3 and 1 are just the primary ones. Now what will also work is 10, 17 and 24 and so on. And the same here, 1, 8. And also we could go the other way, we could go to minus 6, minus 13. Same here, we go to minus 4. So that's our first result there. So let's keep hold of those for the moment. Okay, now let's have a look at this congruence modulus 11. So 23x squared minus 8x plus 34 is congruent with 0 and modulus 11. Okay, now let's break this down by factors of 11. Now obvious one to go here is 2 11s are 22, so put in an x squared. That would be the way to go. Modulus 11, I could add 11 to this one to bring it to plus 3x. So change that to a plus and write 3x. And then 34 modulus 11. Now I need a number in here so as I can factor it. So let's just go with that carefully. So 34, 3 11s are 33, so I could change that to a plus 1. If I put plus 1 in there, I'm not going to get anything to be factorable. So that doesn't look good at the moment. Now what about if I add 11? Then I will get plus 12. Now plus 12 for a difference of 3, I've got 6 and 2, that's not going to work, and 4 and 3, that's not going to work. So 12 is not going to work for me. So how about if I go the other way and do a minus? So what about minus 10? So if I subtract 22, I x squared plus 3x minus 10. So let's put that in there. That looks like it's factorable because 5 2s are 10, difference between 5 and 2 is 3. So that looks promising. So minus 10 is where I'm going to go here. Now, so I can break this down now. Product of factors. So it's going to be using 5 and 2. Now, my coefficient here for the C coefficient is minus. So I'm going to have a plus and a minus. Now, as it's plus 3x, my biggest one is going to be on the 5. So if I put x plus 5 and x minus 2, factor that out, I'll have 5x minus 2x, that's good. X squared is good. Minus 10, 5 times minus 2. So I'm happy with what I've got there. So now, as we did here, let's see if we can solve for our x. So picking this one first, x plus 5 is congruent with 0 modulus 11. So therefore x is congruent with minus 5 mod 11. So bringing this up into a positive number, so add 11 to that, x is congruent with 6 modulus 11. So that looks good to start with there for that one. And now this one, straightforward, I've got x minus 2 is congruent with 0 modulus 11. So now I've got x is congruent with 2 modulus 11. Okay, right. Now these here are my building blocks to try and find my answer. And now what I need to do is to compose all these 4 combined together. So this one will be combined with these 2, and this one will be combined with these 2. And what we can't do is combine the same moduluses to give us our answer. So I'm going to take this off the board, and then we're going to work with these results so far, and then see if we can come up with our solutions for this quadratic congruence. Okay, so now with these results, I'm going to write them down now in terms of their infinite solutions. So for this side on modulus 11, instead of mod 11, I'm going to write it 2 plus 11k. Same on this one, because it's modulus 11, x is congruent with 6 plus 11k. This side I've got modulus 7, so I'm going to use the variable m. So x is congruent with 1 plus 7m, and x is congruent with 3 plus 7m. So I'm going to write up here, k and m are integers. Okay, so now I'm going to combine a and c. So a and c. So here I've got x is congruent with 2 plus 11k. So I'll write that as 2 plus 11k is congruent with 1 mod 7. Okay, so now I need to find k. So now I've got 11k is congruent with minus 1 modulus 7. 11k congruent with 6. That's easier to deal with. Now I need a value of k, so as I've got it congruent with 6 mod 7. So 11, 22, 33, 44, 55. 55 is congruent with 6 mod 7, so therefore k equals 5. So k equals 5. I'm just going to write k equals 5 like this. Okay, now if k equals 5, it could be also plus 7 times my m, as it's modulus 7. So now what I'm going to write is 2 plus 11k. So x is congruent with 2 plus 11k. Now k is 5 plus 7m. So therefore now, let's multiply this out. X is congruent with 2 plus 11 5s are 55. 11 7s are 77. Okay, 77m. Okay, so therefore we've got 2 plus 55 is 57. So x is congruent with 57 plus 77m, which is modulus 77. So that's my first result. So I'm going to write that up here. X is congruent with 57 plus 77m. Okay, right, let's take this off the board and let's combine A with D. Okay, so combining A with D. I've got X is congruent with 2 modulus 11, which is 2 plus 11k. So I now write 2 plus 11k is congruent, as on with D, 3 modulus 7. Okay, right, now let's solve for k. So now I've got 11k is congruent, subtract 2 from both sides, 1 modulus 7. So I need to find a value for k. So 11, 22 minus 1 is 21, that's congruent mod 7. So therefore k equals 2. So now what I write, x is congruent, 2 plus 11 times k. Now as it's modulus 7, I write it in terms of the variable m and 2 plus 7m. So now I can insert that into there. 2 plus 7m, make that a nicer looking 2. Okay, let's finish this off. So x is congruent with 2 plus 22, which is 24. And then 11 sevens are 77, so it should always be a 77. So now x is congruent with 24 plus 7m. Okay, right, let's take that one off the board and let's start working on this b. Okay, so now I've got x is congruent with 6 modulus 11, so x is congruent with 6 plus 11k. So now I'm going to combine b with c. So therefore 6 plus 11k is congruent with 1 modulus 7. Okay, so now we need to find a suitable value for k. So 11k is congruent to minus 5 if I subtract 6. Minus 5 is the same as positive 2. So 2 modulus 7. So we need a value for k. Well, 1 is not going to work, either is 0. 22, 33, 44. 44 looks good because 44 minus 2 is 42. So therefore k equals 4. Okay, so now x is congruent with 6 plus 11k. And k is 4 plus 7m, as it's modulus 7. So insert the 4 plus 7m into there. And now let's work this out. 4 11s are 44, plus 6 is 50. So x is congruent with 50, and 11 7 is 77, as always. So that's now another solution. So x is congruent with 50 plus 77m. Okay, now let's do b with d. So let's use this space here. b with d. Okay, let's do that. So we've got 6 plus 11k. And as we're combining it with d, it's 3 modulus 7. And we need to now solve for k as we did in the previous 3 examples. So 11k is congruent. Now subtract 6, we get minus 3. And minus 3 is the same as positive 4 modulus 7. So now what is our k? So 11, so that looks good straight away. K is 1. 11 is congruent with 4 mod 7. So k is 1. And as it's modulus 7, it could be anything else, 1 plus 7m. So for example, if m is 1, we could add 8, make k into 8. 88 is congruent with 4 modulus 7. So you see how that always keeps on working. So now k equals 1 plus 7m. So therefore we now write x congruent. Now we've got 6 plus 11k. Now k is 1 plus 7m. So let's work this one out. So 11 ones are 11 plus 6 is 17. So x is congruent with 17 plus 77m. So let's write this one in here. X is congruent with 17 plus 77m. And that completes our 4 solutions. So in this kind of composite modulus, we should always get 4 solutions. And that's our infinite solutions. Okay.